Hello, my name is Sarah Vero and I am a second year PhD student with NUI Galway and Teagasc Johnstown Castle, sponsored under the Walsh Fellowship Scheme. And my research is on determining the inherent delay or time lag of nutrients as they are transported from the soil surface to the groundwater below. And this is extremely important for legislation. You see, in order for policymakers to set realistic timescales for mitigation measures to have an effect on water quality, it is essential that they have a thorough understanding of the soil and water transport processes involved. Now ideally you would do this by measuring the movement of a tracer through the soil profile. However, this is prohibitively time consuming in many instances, as it can take up to decades depending on the soil and weather conditions. An alternative is to do what I have been doing, and that is to simulate water and solute movement using a computer model, and I have been using a program called Hydrus 1D. And basically this program simulates the movement of solutes based on meteorological and soil characteristic input data. Now you can describe the soil to the model using a variety of methods, and this can range from very simple techniques such as based on soil texture, which is easily measured, to complex soil hydrological analysis. And what I have found is that when you're concerned about the initial breakthrough of the solute at the base of the profile, generic data such as texture is sufficient. However, if you want to measure the total flushing of the solute, detailed analysis is required. And this analysis takes the form of the soil-water characteristic curve, which is traditionally measured using these devices here. These are called pressure plates. Now these are extremely slow and time-consuming and expensive, but I am working on an improved method using centrifugation, which will allow the same measurements to be taken in a much more rapid and cost-efficient manner. And furthermore, using my centrifuge method, I have identified a major challenge regarding the attainment of hydraulic equilibrium, and this is of serious interest to soil physicists. This improvement will allow data collection to be conducted on a much more detailed scale, which should improve estimates of time lag made using computer programs such as Hydrus 1D. I've also conducted simulations for various soil types in the south of Ireland, and what I've been able to demonstrate is that not all soil types are equally capable of attaining the water quality objectives outlined in the European Union Water Framework Directive. Furthermore, I have installed sensors in arable and grassland sites. This will allow me to validate the estimates of time lag made using Hydrus 1D against in situ field tracer tests, and thus to determine how accurate the model truly is. Now that's just a very brief overview of my PhD research so far, but if you have any questions or comments, please don't hesitate to get in touch at sarah.vero@teagasc.ie. Thank you very much for your time.